Hi and welcome to another video. Today we're going to talk about data structures. This is the second of the Julia Tutorial 2021 playlist, and we're going to see arrays, tuples, dicts, and some kind of small tricks with them that you can use to play around with your data. Okay, so we're going to dive into the notebook straight away. By the way, in the description you can find the link to the GitHub repository where this is posted, and you can download everything for free. It's all available in GitHub. Okay, so data structures, what are they? Which kind of data structures do we have? What can we do with them? Let's check it out. So we have different kinds of data structures, and well, they have different properties. So some of them are ordered, some of them are mutable, and we're going to use each of them in depending on what we want to do. So here I made a quick table of which data structures we have and which are ordered, mutable or mutable. There are more data structures than that, but we're just going to stick with these ones because they are the main ones. What do we mean by ordered and mutable anyway? So ordered means you can say, okay, Julia, give me the first element of an array or of whatever it is, and this is going to work. If you say that for a dictionary, for instance, it's not going to work because dictionary is not ordered. So it does not have a first element. There's no first element. There's no second element, and yeah, you have to call each element specifically. But we're gonna see that. And mutable means you can say, okay, take this element and change it to this other value, and that's going to work. Okay, so the first part is tuples. Tuples. Let's say tuples. So here it is. So this is the first tuple. ABC easiest one to see. You see the syntax is with parentheses for tuples and separated by commas. Now, if you try to call the first element of an array, remember Julia is one indexed, meaning that the first element is the first element. In Python, it would be the 0th element. So if we do that, what happens? You see that we get an error. This is because tuples are not ordered. So you can't say given the first element, it doesn't work. Okay, and sets, we have sets. Sets are kind of like mathematical sets, obviously because they're called sets. So you see, like, we've got this set here. This is we can make a set using the set and then parenthesis notation. And you see we have 1, 1, 2, 3, and so it's repeated here, right? We have twice the element 1. So if we run that, what happens? You're going to see that we don't have the 1 appearing twice. We only have it appearing once. And this is one of the properties of sets, is that you don't have duplicate elements. So this is pretty useful, and you can use it in some applications. And you also see that there's something else you might have noticed. This is not in the same order as it was here. And this is another property of sets, is that you don't necessarily keep the order. So this is something you need to be really careful about, because if you have indices like that, or elements, should I say, like that, you may expect that you're going to get, when you print them, if you print all of the elements, you're gonna keep them in the same order, but that's not the case. So just be careful with that, because it can get tricky. Now, if we take my set and we try to get the first element of it, what happens? We get an error. We can't call the first element of my set. Okay, so yeah, beware of these things and use sets wisely. Now we have dictionaries, dicts. So the way to make a dict is using this syntax. I believe you can also use curly brackets here, but for here we're going to stick with this. And then the notation is oranges, or should I say keys, in this case oranges, and then the value they have. So like I've wrote here, key 1 value 1, key 2 value 2, and this is how you declare a dict. So we're just going to run that, and now there you go. That's what you get. So you see that if I say, okay, what is the prices of oranges? It's going to give me 3.5. What is the prices of bananas? It's going to give me 4.0. And you see once again that we don't have the same order as we declared them here, meaning that we have oranges first, here oranges, okay, but then we have apples, and then we have bananas. So it's not the same order as we declare them. That's a property of dicts. Okay, we have methods we can apply on dicts or functions. I always get them confused. We have the keys. So keys is basically what you put before this arrow, and values is what you put after this arrow. Note that you could have had other things in here. So you could have had, for instance, an array. We're going to see arrays afterwards, or maybe I should use a tuple because we saw these ones already. So we could have something like that, right? And yes, no problem. We see that you can have a key, and then you can have the value being pretty much anything actually, even a dict. I believe, I'm pretty sure about that. So yeah, that's very convenient. You can store things and only ask for the key, and every time return the value. This is super useful because this way you kind of link elements together, and that's something you use quite a lot. Okay, anyway, let's redeclare the dict that way. So here you see we linking the keys, which are the fruit, with the values, which are the prices, like in euros, for instance. And this is super useful because you can't just say, I have some prices and I have some fruits, but then you don't know which is which. You don't know which is for which. So that's why we use dicts for. And you see here we can print all the keys. So look at the syntax here. When you use this $, it basically means that this is a variable. And here we're inside of a string. Remember we did strings in the previous video. But this means that the k is not just the letter k. It means that it's this k thing, which is a variable. So here we're saying, okay, for each element that we call k inside of the keys of the dict prices. So we're saying, okay, look at this one, and then look at this one, and then look at this one, and we're going to iterate over these three in this case. And here we're going to print. Remember, print is with print ln because this is due to syntax. And we're going to say, give me the value of k, and then just write this. So it just copies it, and then give me the value of prices of k. So this is the way we write we get the value. So if we say prices of orange, or oranges, prices of oranges, we're going to get 3.5. So that's what happens here. So we say oranges, here we get oranges, and then cost, and then price of oranges. So 3.5. And remember, in Julia, you can write these symbols. You can write Greek letters and many other kinds of symbols. And the way to do it is to type them like that. You type \, and then the kind of code for the symbol, and then you hit tab, and there you go, it transforms it. Just looks nicer, right? And yeah, no, don't forget the end keyword. I tend to forget it a lot because I come from Python, but yeah, remember not to forget it. Okay, and now same thing with values. We can reach the values of the dict, and we're going to do exactly the same as above. For v in values of prices, sorry. So that means get me this element and this element and this element. Remember, they're not necessarily in the same order as you declared them. So if I run that here, you see we get 3.5 and then 4.0 and then 1.5. So they're not in the same order. The thing though is that we don't get the key for each value in this case. So it can be useful, but you kind of lose the link between the key and value in this case. But good to know. Now we get this, collect prices. This is pretty useful actually. And you're gonna see what it does. So note that this is a vector, meaning that you have 3 elements here, as noted here, and you can access them. This is now an array. Well, it's a vector, but for many purposes you can use it as an array. We're gonna see arrays afterwards. Maybe I should have started with that, but yeah, there we go. Call equals collect prices, and now we can say call of 1, and there you get the first element. And now you can do something pretty cool as well, which is that if you want to get oranges now, you can just do of 1 again, and you get oranges. So note the way things work here. You get call, which is this collect of prices, and I wrote array here. It's not really an array, so maybe I should write some kind of quote. And if you want to get the first element of that, it's going to give you this one. Remember that since dicts are not ordered, you're not sure that this is going to be whatever you declared first, so it's pretty tricky, but you're going to get some element. So I'd say I get the first one, whichever it is. Oh, it's this one, and now you have an array. So now if you call the first element is going to be the key of this key arrow value collection, and that's going to be oranges. And now if you take the second one, it's going to be the value of this. So it's going to be 3.5 because the 3.5 is what's after the arrow in this case. Okay, now what we got here? We got two dicts. Okay, so again, they're not in the same order, and you can notice that they have some similar keys, namely 2. And we're gonna work with unions, intersections, and set diff. You're gonna see what these do. So here we've got the union, and look at what happens here. We have the first dict, which is 1 is sent to A, 2 is sent to Z, 2 is sent to B for the second dict, 3 is sent to C, and 4 is sent to D. So we've got two different dicts here, and we're going to take the union of them. So the union is like in math, it's basically taking both of them and putting them together. And that's exactly what happens here. So you see that this is a 5-element vector, meaning that it's actually the same thing as that. It's a vector, and you can therefore repeat elements. So you see here we have 2z, 1a, 4d, and then we have 2b. So the key 2 is actually repeated. And the way you get these elements is not by taking the key 2, is as we did before. Is actually if you want to get 2, which is sent to z, you're going to take the first one, and that's what it is. And now the second one, and the third one, and the fourth one. And you see both keys and values with the key being 2 are actually in different positions, and they're not at all called by taking the second element. This 2 here means the second element of this vector. So yeah, just be aware of that. Now intersect, we've got nothing because we've got no element in common. Now if I change that and I run that, you see we have 2 is sent to A and 2, oh sorry, that should be a B. So 2 is sent to B here, and 2 is sent to B here. And these are in common. The other ones are not in common. The other ones are different. And now if we run that, you see in like the first time there was nothing in this pair of int64 and string. And now if we run that, we have 2 is sent to B because it is both in dict1 or d1, should I say, and it is as well in dict2 or d2. So that's the intersection. Now the difference, set diff, so it's like the difference between d1 and d2, is all elements in d1 which are not in d2. So you see we have this 2 is sent to b, which is in d1 and d2, but 1 is sent to a is in d1 but it's not in d2. So that's why this is the answer. It's because you read it as giving the difference of all the elements which are in d1 but they're not in d2. And it doesn't work both ways. I mean, it works both ways, but you don't get the same result. So if we change the order, then we get 4 sent to D and 3 sent to C, because now we're saying, give me the elements which are in D2, but they're not in D1. So now we get 2 sent to B is also in D1, so we're not getting this one. And 3 sent to C and 4 sent to D, these are in D2, but they're not in D1. That's where we get them. Okay, arrays now. Arrays are made with square brackets, and they're very nice. They're ordered, they're mutable, so life is beautiful. The drawback though is that you lose some speed. So if you're sure that something is not going to change, I believe that using tuples or maybe sets is going to be faster, because basically since Julia knows that you're not going to change those ones, it's able to perform some optimizations, and therefore it doesn't have to, like, it can go quickly because it knows you're going to change it. So here we declare cities, which is an array from the square brackets, with Paris, Nice, and Monaco. By the way, I'm French if you didn't know. And here we call pi. We can also have this. So you see here vector with strings, and this is a vector with int64, meaning that this is the elements we've got in there. Now if we put something else, what happens? If we say 9.8, what do we get? We get float 64. So now basically everything got converted to float 64, even though they're all ints, but Julia converts those to int64. Now had we had a string in there, I don't know, USSR, and that was very random, then we get any, because it can't really convert USSR to anything in common with the other ones, so it just gets any. So it's like we have some of ints and then we have some of strings, but I can't really mix up something so that everything fits nice together, so I'm just going to give you any for all of them. Anyway, let's go back to 9. Okay, types. If I run that, you've got one hell of a mess. So the type of, look at these, they're a bit messy, but I'm sure you'll get it. The type of one is type of one. The type of hell of a mess is hell of a mess. Well, it is type of hell of a mess. And you see the pattern here, right? So the type of 1.0 is flux 64 because it's got this 0.0, remember? The type of hell of a mess is a string because it's got these quotes here. Now the type of 4 is type of 4, so that's going to be int, and type of u is type of u, so that's going to be char. By the way, someone told me in the comment last time that it's char, actually not car, so I'm very grateful to my friend who told me. Okay, so basically you can see that this is one hell of a mess, as the message says, and in this case we get any, as we mentioned before. So it means there are many different types. I can't really convert them to one unique type, so I'm just gonna say any and have fun. Okay, now something super important. I kept it for the end, so hopefully you stuck to the end and you're gonna hear about it, because this is super important. Is array comprehension. So look at what's going on here. You're having this square bracket thing, and then inside of that you've got x squared for x in 1,4. Remember what 1,4 is? 1,4 is all numbers from 1 to 4, so it's going to be 1, 2, 3, 4, and inclusive. So in Python it would be different, for instance. In other languages different as well, but in Julia it means you go from 1 included to 4 included as well, and then you do something on all those numbers. And look at what we're doing here. It says we're taking x squared for x in 1,4, meaning that for each of the values in 1,4, so 1, 2, 3, 4, you're going to square it, and look at what we get. Exactly that, right? So we get 1, which is 1 squared, 4, which is 2 squared, 9, which is 3 squared, and 16, which is 4 squared. Now we can do the same, but a bit, well, we can change that first. Let's change that first so that you get a grasp of it. You can say x cubed, and you see that everything is cubed here. We can say 2x, so 2 times x, and you see that we get the pairs, like twice 1, twice 2, twice 3, twice 4, and these are the results we get here. And now we're getting something a bit more complicated. Let me make some space here. So what have we got here? That's a mess, right? It's okay, it's not too bad. So this is the first part. So you should look at everything before the for keyword, and this is where you're gonna have the expression of whatever we're gonna do. So we're gonna do 2 times x plus 3 times y, okay, for x in 1,4. So that's the second part. So we take x in 1,4, but first we fix x. So first x is 1. So you see here x is 1, and then y is 1 as well. That's the first step, right? And then what it does is it takes y equals 2. Oops, 2. This is 8. And then y equals 3. This is 11. So you see how we are following what's going on here? And then we are at the end of that, right? Because we said for y in 1,3, but now we are at 3, so we don't have anywhere to go any further, right? So now we're incrementing this one. Incrementing means increasing. So incrementing of 1 in this case, increasing by value of 1. So now we're going back to y equals 1, and now we're changing x to 2, right? And now we get 7, which is what we get here. And you see the pattern here. Now then we're keeping the same x, and then we're going to y equals 2, that's 10, that's the next one, and then we're going to y equals 3, that's 13, and keep going, right? And then the last one, obviously when it's going to stop, is 2 times 4 plus 3 times 3, and that's 17, right? Okay, so that's list comprehension. This is super useful. This is used all the time. And just as a side note, what we could have done instead of that is for x in 1, 4, and then we could have made another for loop, which would have been for y in 1, 3, print, we're going to print 2 times x, well, we're going to print that. Sorry, it's a new keyboard, so I'm not super used to it yet. That's what I meant to go here, and then remember we've got to end the first for loop, or the second, like the inner for loop, this one, and then we need to end the other one. And then if we run that, look, we get exactly the same output, right? 5, 8, 11, 5, 8, 11, 7, 10, 13. Yeah, we get the same output, right? So this is actually what it does, but this is one line and it's way more concise. And people tend to like using that if they can. And there's actually one more thing that I'm going to mention before we wrap it up, which is that, look at that, this is a vector. So this is actually, as you can tell by the squared brackets, this is an array, right? So I could say like r equals this, and then if I want to do, like if I want to print r, then I get the same thing, right? You don't see it because it appears by default on Jupyter Notebook, but here this thing is stored in the value r. And now I can do stuff like indexing, for instance, which is a good thing we're gonna be able to check, which is like if I want to take the second element, it's gonna give me 8 because see the second element was 8. Now if I want to take everything from the fifth element, I'm going to do 5 and then colon. Oops, that was meant to be 5, and that's an error. Oops. Oh, sorry, it's 5 until end, obviously. So that means take everything from the fifth element. So we count 1, 2, 3, 4, 5. So this is the number 10, and then we get everything until the end. So what we get is this. Okay, that was a very Pythonic way of doing it. Sorry, we just write 5 colon and then it gives everything until the end. But if you want 5 until 7, you say 5, 7, and then you just get those elements, right? But basically, this is an array. So we've got this variable stored. Here, we're just printing. So if we wanted to do the same thing as above, just quickly, I'm going to show you. We would have to do R2 equals, and then this square bracket thing. And then we would have to go for x in 1, 4, for y in 1, 3. Instead of this, we would have to do append with an exclamation mark, meaning you're going to append in place to the R2 array. So this means append to this array this value, right? And that's going to give us hopefully the same thing. So now if we check out R2, we get the same thing, right? And now we can do the same operations. We can do 2 to 5 and same as before, right? But look at how many lines we needed for that. If we would just remove the place where we call it, and here we remove it, look at how many lines we need for that. This is one line, and you've got everything at once, and this is 1, 2, 3, 4, 5, 6 lines, if I can count correctly. So this is 6 lines to do the same thing as one line. So obviously comprehension is extremely useful. And obviously you could keep going if you're a little crazy. You could go for plus z, and then you could go for something like for z in 1, 3 or something. And yeah, you can get pretty crazy with that if you keep going. Anyway, that was it for today. So I hope that you enjoyed the video. If you did, please like it, subscribe, and comment, and do all the YouTube things. And yeah, let me know if there's anything else you want me to cover in Julia. There are tons of things. I'm learning just like you are, so I'm obviously not an expert yet, but hopefully we'll get there together. And yeah, I'll see you in the next one.